Hey guys, today we're going to be dealing with some higher level trigonometric functions. And I'm only going to have two problems today, but it's going to be a lot because these problems are sort of tricky. Alright, let's go ahead and start. These are all going to be prove. Prove that, by the way. First one's going to be cosine to the fourth of theta. And this time, for this problem, I'm going to use theta because you should probably get into the habit of seeing one or the other for the variable. So cosine to the 4 plus sine squared theta equals sine squared to the 4th theta plus cosine squared theta. Oh, well, looks like I need to write smaller. Okay. So when you look at this problem, you might find it sort of weird how the 4 moves over to the sine and the 2 moves over to the cosine from the sine. But you do know that from this identity, you can easily have the cosine, for example, equal a sine squared. Or vice versa, you can have a sine squared easily equal a cosine squared. And the first thing to do when you see problems like these, and there's, a bunch of things you can do, you want to look at the other side of the equation. You want to see what you ended up with. And that may give you a hint as to what you need to do to get there. So immediately I see a sine to the 4th, and as of now, I don't know anything, although I did do this problem before. At first, I had no idea how to get this 4 to that 4. But I think we can figure stuff out as I just start working this problem. Okay? So cosine to the 4th, that's also the same as cosine squared times cosine squared, right? And I change it to the squared because you probably want to use this identity somewhere in there. Plus sine squared theta again equals sine 4th plus cosine squared theta. Oh, dang it. I must keep on running out of room. Anyway. Okay. So now I can see something that I can do. This is because I know that I need a sine to the 4th. And I obviously can't get it out of the sine to the sine squared. So the only place I can get a sine to the 4th is from here. So I'm going to go ahead and deal with this and use maybe another identity to get to the sine to the 4th. And do you have any idea what that identity might be? Of course, it's this big guy over here. Alright? So rearranging this, you know that cosine squared also equals 1 minus sine squared theta times another 1 minus sine squared theta plus sine squared theta. And since I'm running out of space, I'm just not going to write this side of the equation. I'll just have it go all the way down. Okay? I mean, because, yeah, you know what it is. So now at this point, there's really not much you can do except for foiling this out. So let's go ahead and do that. So 1 minus... I'll just make this simple or quick. I know you guys know how to FOIL. So 1 minus 2 sine squared theta plus sine squared to the 4th, or sine to the 4th theta, plus another sine squared theta equals all that jazz. Yeah. So now it actually becomes pretty simple. You already found your sine to the 4th, so hallelujah. And now you're just left with, ignore this now, all you have left is this and this. So we're going to go ahead and add like terms. Plus 1 minus sine squared theta. Remember, still equals sine to the fourth plus cosine squared. And guess what? You're going to use this identity one more time. See how important it is? This is the identity you must know by heart. And it would actually help if you knew how to rearrange it by heart, so you wouldn't have to do it every time. But off the top of my head, I know this is cosine squared, right? Because cosine squared equals 1. Moving this over, cosine squared equals 1 minus sine squared, which is what you have here. So let's go ahead and replace that. Plus cosine squared, and there you have it, guys. Equals sine. Oops, I actually get that arrow should be drawn there. Plus cosine squared, and your proof is complete. Oh, one more thing. Sorry, I didn't say this in the last lesson, I think, but whenever you're, solving a proof, at the end of it all, you want to make sure that you set what you found equal to the original trigonometric function they gave you. Okay? That's just, some formality that we need to deal with. So be sure to always do that. Alright, let's move on. Alright, now this next problem I'm going to give you is one of the nastiest problems out there that you'll probably see. Oh, sorry, I felt a sneeze coming. Wait, it's coming back. Oh gosh, I hate it when that happens. Never mind. Sorry, guys. Really thought I was gonna sneeze there. Dang it. Alright. Next one. Secant x cosecant x plus cotangent x equals tan x plus 2 cosine x cosecant x. Oh man, I really do need to write smaller. I'm sorry, guys. But anyway, yeah, when you look at this identity, you really have no idea where to begin with. And honestly, I don't either. But for this lesson's sake, let's just say you want to simplify everything, because I think that's a perfectly rational thing to do. I mean, you simplify what you can simplify. Right? So let's go ahead and get started. Secant x, that's 1 over cosine x, right? Times cosecant x, that's 1 over sine x, plus cotangent x, what is that? That's cosine x over sine x. And then just leave these as they are. We're not going to deal with this side. Okay. So now what you have is a series of fractions on this side. And before I said we were simplifying, but okay, yeah, I lied. This is not simplifying. This is making it more complicated, but it's the only thing we can do, honestly. Alright? So, yeah, let's just write this out to the side. When you simplify this, what does this become? Cosine x sine x. I just combine the denominator together. And since we have this ugly fraction and another fraction, we want to put them together, right? So first of all, you need to have a common denominator on this fraction. The way we do that is making sure this matches that. So all you need to do is multiply this by cosine x over cosine x, right? And that's perfectly legal because cosine x over cosine x is 1. And multiplying something by 1 does not change its value, of course. okay? So now you have, what you have now is 1 plus cosine squared x over cosine x sine x. And that equals tan x plus 2 cosine x cosecant x. Right? Boy, this is a mess. So now there's two options that you have. And I'm just gonna go ahead and tell you straight flat out, this first option I choose will lead you to the wrong answer. Okay, but I'm gonna go ahead and do it because it really does seem like it's the right way to go. And there's really no way you can see that it's wrong until you get there. Which is why most people hate the identities unit. Don't worry, I did too. But anyway, what I'm gonna do is change the cosine squared x to 1 minus sine squared x using the identity sine squared plus cosine squared equals 1. Remember that? Of course you do. Good. So, what that becomes is 1 plus 1 minus sine squared. Oh, whoops, I wrote theta that time. Sine squared x all over cosine x sine x. And that equals, of course, tan x plus 2 cosine x cosecant x. Alright? And the reason why this really looks like it's gonna work is because you end up with a 2, right? 1 plus 1, you end up with a 2, and on the other side there's another 2. So, I mean, yeah, like, this looks like the right way to go, honestly. So what you have is 2 minus sine squared x all over cosine x sine x equals tan x plus cosine x cosecant x, okay? And remember what I said last lesson about the denominator. If it's one term, then you can separate it. Separate the fraction, 2 fractions, or however many terms are on the top. So 2 over cosine x sine x minus sine squared x over cosine x sine x. And I honestly think this problem is one of the most evil problems that has ever been written, because this almost gives you the right answer, but it's not quite. Okay? Hear me out for a second. 2 over cosine x sine x. That becomes 2, and using the reciprocal identities, secant x cosecant x, and this becomes, if you cross out the signs, that becomes tangent x. Okay. But you see how we have two problems here. First of all, the tangent x is negative in this equation, whereas it's positive here. And another problem is you have a secant in place of a cosine. Okay? And I don't know about you, but I have no idea how to rearrange this or fix this to get to there. And what this means is that you've really been stuck at a dead end. And this is probably one of the most horrible things about this unit, because there's really no way you could have seen it coming, right? Because you saw the 2, and you're like, oh, I should go for it. I mean, you got the 2, and I even ended up with a tan x, which is actually really close. But that is not quite the right answer. Okay, guys? So what I'm going to do now is go back to the step where I had more than one option, which is this step right here. I'm going to go ahead and rewrite this step on a different piece of paper, but Yeah, just know that we're starting from this step again, okay? So going back to that step, it was 1 plus cosine squared x all over cosine x sine x equals tangent x plus 2 cosine x cosecant x. Alright, you may not have seen it, but our second option here is to manipulate the 1, alright? And it's using the same identity to manipulate this actually. It's of course the sine x squared plus the cosine x squared equals 1. And so we can simply plug that in for 1. And I'm just going to draw an arrow for this down. Just remember that. Alright, you're probably wondering how in the world this is any better than the first option, but it really isn't actually. It isn't better. It makes it more complicated, but it's the only way you can get to the right answer, at least from my knowledge. Alright? So, once again, you have this single term denominator, so I'm going to go ahead and separate the fraction. Oh man, I'm gonna run out of room. Equals that, of course. Yeah, here we go. Now let's go ahead and start canceling. That leaves you with this. Oh yeah, this is the same thing, of course. Cosine or sine x. Right? Okay, so now you have a tan x. Oh, wonder where that came from. And then you have these two terms which are exactly the same. So when you add them, you can combine them and put a 2 up front, right? So that's basically 2 cosine x over sine x. Yep, there you have it. All that's left to do, looking at the answer, you can bring the sine x up, change that to the cosecant, right? And then you'll have the answer. Let me show you. Plus 2 cosine x cosecant x equals tan x plus 2 cosine x cosecant x. And finally, we are done with this dang problem. Yeah, look at this. That was quite the mess. Yeah, I would actually, on a test, if you went through all this, I would just cross it out and then rewrite this step somewhere else so you can work it out again. Alright. So, just one thing I need to say. Whenever you're dealing with this kind of trig equation where it's sort of difficult and you have no idea where to even begin, take a look at the answer, okay? The answer will always give you some clues as where you need to work or which direction you need to go in. In this case, I thought I was going in the right direction, but I still ended up with the wrong answer just because of the cruelty of this problem, honestly. But chances are you'll encounter a problem like this on your test. So that's why you really have to be prepared, okay? This answer can only help you so much. The rest is up to you and making sure you get enough practice in so you're experienced with these kind of equations. And unfortunately, that's not something I can teach, but for your test, make sure that you've got enough practice so that you're not wasting time while you're trying to simplify the equations. Okay? I took a lot of time on this problem, and you will get nowhere near this amount of time on the test. Alright? And I hate to say it, but the last little thing and throughout all this is just a matter of luck. Okay? If you ever see a problem like this, it's a matter of choosing the right path to go down. And if I'm trying to be all deep about this. But yeah, that's about it for trig identities. And I hope throughout my teaching you've learned something new, or you've been more open to what it's gonna be like on the test. Alright? Good luck, guys, and thank you for watching once again. Alright? Bye-bye.